Okay. Just test if we are good. All right, and we are live. Okay. Cool. Yep. So some linear algebra homework and some. We'll see if I get to this, but mostly just want to do a problem or two, just because. Yeah, for the sake of doing it, right? Cool. So this is a part of a graduate course I'm taking this semester. Yeah, honestly, I'm not doing the hottest in the class, so this is pretty helpful. Okay, so how does altering the direction of the edges of a diagraph affect its incidence matrix? Co-kernel of its incidence matrix. Then can you realize this operation by matrix multiplication? Yeah. So, yeah, so the, I guess for this it's just like helpful to talk about like what exactly is each diagram is in a diagraph, so, or in an incidence matrix. So an incidence matrix just has like ones, negative ones, and zeros like per row, where -1 represents sort of like the head of an edge, and a 1 represents the tail. And zeros are pretty much every other vertice that's not necessarily affected. So if you alter the direction of the edges, you're essentially altering where the ones and the negative ones go in the incidence matrix. Yeah. So like 1 again represents the tail. I'm like writing this down in my notebook right now. Sorry. Oh shit, my loop is off body still. So the kernel now represents all the circuits, right? So if we alter the direction of the edges, we potentially alter what circuits actually exist, right? Wait, is the co-kernel a subspace? Cool. Yeah, so I was right, yeah. So the co-kernel of an incidence matrix represents the subspace of all circuits of a digraph. So by changing I wonder if like by okay, yeah. This is just like an English clarification question. Okay, yeah. So by changing directions, so we solely like each individual circuit vector and co-occur but like the co-kernel itself is still essentially just like spanned by the same vectors. Spanned by the same vectors still. So then can we realize this operation by matrix multiplication? Oh, X, so I don't want to see you again. So like, can we realize this operation of altering the direction of the edges? Yeah, we can just multiply by the inverses, no? Not the inverses, but like... So, to realize this alteration, I wonder, honestly. I don't want to see you again. I'm just alright to just make sure this is still going. Cool. We're still moving. Be friends. So just Just make sure this is still going. Cool. Yeah. So realizing this operation by matrix multiplication means realizing how long the strings is going on for. Say time. I'm unsure actually. Only about 12 minutes, 10 minutes. Cool. Yeah, 11 minutes ago. Can we realize this operation? I would say yes, it's entirely possible, because all it really means is taking is I see. So it's possible, but only for the entire thing. Yeah. D is a diagonal, make sure the plus one diagonal. It's not reducible to scale. Each diagonal entry D controls one row. Yeah, that makes sense actually. So, yeah. Yes. Consider nice. Good work, good time. It's about 3:35. Honestly, it is a bit late. This could not have been more poorly planned. I have to cut today short, which is sad. but I do really have to sleep. I have to wake up in like 4 hours, so there's 3.11. 1, 2, 3, 4, 5. 5 more questions. 3.11, which is inner products and norms. Yeah. Prove that the formula VW defines inner product on okay, yeah, if and only if B is greater than 1. Yeah, I mean, what we have here is just ain't fair. Okay, so I just have to prove that it holds under bilinearity, right? Which is, we did that already? So, two vectors in the same vector space are orthogonal if their inner product is equal to 0, which is simple enough, right? Carried away. No way. Back to us. Okay, wait. What does Euler's theorem say? Euler's theorem, the number of vectors plus the number of indices equals the number of edges plus 1. Not connected graph. Okay, whatever. So pretty much all this is that we have to check the 3 properties, right? Bilinearity, symmetry, and positivity. So Okay, so essentially what it's saying is that b has to be greater than 1. So we should prove it under b being greater than 1, and then show, okay, so first we need just underlying the fact that it has to define an inner product, and then we can make it so confirm that it defines only if b is some right, if and only if b is some like positive value, right? Fuck, it's late. I honestly think I'm better off just sleeping this off and just doing this in the morning. Okay, maybe we do that. Then we continue this stream in some hours, whatever. This can be like a two-parter. But yeah, I mean, I am pretty tired, and I think I'm just better off maybe sleeping here. Yeah, probably. Yeah. Oh, so yeah, sorry. Yeah, I mean, yeah, we could do I'll do part 1. Save. Cool. Cool. Alright, well, I shall see you guys in sometime today, probably.